Oh, that looks fine. All right, good morning. My name is Linden. I'm with the Chrome Media team, as Anatoly said. I'm going to talk about WebRTC and more specifically get into the video codecs and video used in WebRTC. But I'll start with a little bit of, if you will, a repetition of what just happened. So let's start at, so where does this come from, WebRTC? It comes from what is happening on the web. And David showed some nice pictures here. Here's an animated attempt to show what's happening in the web development and the development on the browsers. So you can, the colors here, these things, they show the different technology. And what you see is how it started out pretty slowly with just being able to render static text pages. But now it's just everything is getting in there very quickly. And this is what makes the whole thing so exciting, because it's not only a few technologies here or there. You can combine a tremendous amount of really powerful technologies. I'll talk a little bit more about that a second here. Okay, so there are a few prerequisites for the web to be really powerful. And one thing that is really key is the adaptation rate, how quickly the browsers and the applications are updated. And I'm happy to say that today we are at the vast majority of users get browsers that are updated as often as every 6 weeks. That means that you always have an up-to-date browser, and that makes the platform extremely powerful, something you don't have in the native world. So why is the web so attractive? Of course, we all know that it's a great place to be. But one thing that I really want to stress here is that, again, the browser and the apps are updated all the time. So you don't ever have problems with interoperability or issues with end users being on the wrong platform. Of course, the benefits of discoverability and search, etc., the easy access to cloud services, and the wet dream of all developers develop for one platform. We're not quite yet there. The mobile is a little bit different from what you do on the desktop, but it's getting closer and closer, especially when mobile. And this is an important point for I think for video in particular, is how the tablets are really becoming the new laptop or notebook, and therefore you consume a tremendous amount of video on those rather than the phones and rather than the regular laptops. So that's your new mobile, and that's where the really big growth is coming. And that's what we're seeing on our platforms. What's really nice with the web too is the security. Many people feel like, oh, well, the web, that's insecure and all that, but it's actually a much more secure place to be. You can see that from the Chrome OS devices, for example, where you only have the web and we have no problems whatsoever. There's no malware, there's no viruses, there's nothing. You're totally secure because in the web we can control who you get what from. And of course, it's free. So what is HTML5? So my preferred little simple equation is this. HTML5 is basically regular old HTML3 or 4 or whatever you want to call it, plus CSS to make nice formatting, very easy and powerful, and then JavaScript. And with JavaScript, we can do anything. So there we have a programming language that makes it possible to do things evolving, but also a platform to get into what the browser can build into it. And again, mobile is really coming about. For just going back 2 years ago, there were basically no HTML5 web browsers to talk about on mobile. And now everything is getting there. So both on Android and iOS, you have very powerful HTML5 browsers. Okay, quickly into WebRTC. So what WebRTC does, it really creates a communication hub out of a browser. So suddenly we can now communicate in real time and also streaming, whatever, from any client to any client. So not server to client as the usual model has been, client to client. That's the big difference. So why is this so important? So this is, so actually about 3 years ago, the Chrome team sat down and did a long list of what are the things that we're missing on the web platform. What do we need to address for this to be as powerful a platform that you can do all the essential things you want to do that you today can do in native applications. And the number one item on that list was real-time communication was missing. This is what started WebRTC. They acquired the company I came from. We've developed an open source platform for WebRTC and started the whole standardization effort. Because without this, there's a big gap between what you can do with native apps or downloaded plugins. So that's addressing that big gap. And now when we pretty much have that done, we can move forward and see how we can integrate that into other things. Because this is the thing. One of the things I think is most important to understand about WebRTC. WebRTC is not a new application. This is a technology that integrates into a platform where you can integrate it with all kinds of other technologies. That's the whole idea of the web. That's the whole idea of WebRTC. Make it easy to put real-time communication into anything and seamlessly. Any developer, instead of a few thousand audio and video developers that can do this potentially, now you have millions and millions of web developers that can do this easily. That's the whole benefit. Getting the APIs up to a level where anybody can do it, getting it in the hands with really high quality of every client out there get that, instead of having to licensing or buy or build something really complicated. Yeah, so this is just a few of the technologies that we easily integrate with. So again, that's the whole thing. Make it easy to integrate with other technologies on the web. And in terms of media technologies, the pieces all there. You have the audio and video tag for streaming. You have EME and MSE for adaptive streaming and for content protection. WebAM for Codecs, WebRTC for real-time communication, pictures, WebP. Also speech recognition, web speech, and the latest thing we're experimenting with is to be able to do audio stuff, really high-end audio stuff through Web Audio API and the Web Media API. So, what about codecs in WebRTC? Video codecs. I won't talk about audio here. I will only talk about the video part. Obviously, there are some key requirements that make total sense, like that it should be high quality, should be really optimized for real-time communication, which means low latency, adaptive to very quickly changing network conditions, robust against the mobile networks, etc. Obviously, we have to consider mobile all the time, so complexity has to be reasonable so it can work on low-power devices. And therefore, hardware availability is an important factor. And of course, has to be a reasonable cost, both for developers, for the browser manufacturers, and for anyone that wants to do something with this. There's also a specific issue, and you saw that on David's slides, that there are a couple of browsers that are really, really popular, that have a significant part of the market, that are open source based and they can't integrate technology that requires IPR licensing that isn't free. So that's a requirement then for them to be able to include them. So today, where WebRTC stands today is available in Chrome and Firefox and very soon in Opera. And all of those three use VP8 because VP8, as we'll see, fulfill these requirements. There's been a long discussion going on about mandatory to implement codec in the IETF for WebRTC. that has not yet come to any conclusion, while it has done that for the audio side. So let's talk about the codecs, and why do we do this? You probably all know that Google is behind the VP codecs, and we do that because we really think it's very important for the web to have access to high quality, free and open alternative web video, and something that develops very quickly. It needs to develop at the same pace as the web. And the web isn't sitting and waiting 9 years to develop a codec or a new technology. It has to happen much, much quicker in order for keeping pace with the tremendously innovative developers you have out there on the web. And obviously, we all benefit from this. The web is a tremendous vehicle to make money and to reach anybody with any kind of purpose you want. So that's the background for why we developed these codecs. So let's talk about VP8. So VP8 was launched in May 2010. It's an open source project as part of the WebM project. What we tend to believe is a really good trait of this codec is that there's only one profile. So every implementation will be interoperable. And also the implementation that we provide is free, both in hardware and software implementations, making it easy for anybody to take it. You don't have to optimize yourself, find and make an implementation that is good. There's plenty of hardware out there that supports both VP8 encode and decode, and is widely deployed. Especially nice now that we just launched Google Hangouts in HD, and that's based on the VP8 codec. So that's a nice achievement based on VP8. So going back to the key requirements for WebRTC, this is the reason why VP8 is being used there today. It fulfills all those requirements. It has the high quality. It is working really well for real-time communication. It's available on hardware, but also sufficiently low CPU consumption that you can run in software almost everywhere, and it's open source and free. In terms of IPR, Google has developed this codec, has all the key IPR in it. There was a VP8 pool initiative at MPEG LA, but after we reached a license agreement with MPEG LA, that has been disbanded, and there is now a license where we have the sub-licensing rights to give it away to anyone. So what's next? So this talk was about video for WebRTC today. That's VP8. Next is VP9. I think it's important to start with saying this is absolutely next, not today. Don't confuse, oh, there's a new codec. Maybe there's no reason to consider VP8 then. As you all know, it takes a while before you have hardware and everything optimized. So for now, VP8 is the good codec for WebRTC. VP9 is currently mostly focused on streaming, will get better for real-time communication soon. So why do we develop a new codec? Same reason as HEVC. VP8 is good, but the demands are increasing, and the amount of video traffic is increasing extremely fast, and we need to keep up with that. And one of the major costs, as we know from YouTube, obviously, is the bandwidth cost. So being able to cut that in half, that makes a significant saving. And that's absolutely, excuse me, something that needs to be done. And which also means that there is a need to develop new codecs in the future. So VP9, how do we develop in the WebM project? So the way we do it is we have an experimental branch, and that was open at the same time as we open sourced VP8 and launched that. And there anybody can contribute, and there's been a lot of ideas and contributions from others than us into that branch. And then late 2011, we started focusing a little bit more on a new codec, and in middle of last year, that's when, okay, now let's build a new codec. And we started putting pieces together. And the release was in June this year. So since then, the bitstream has been frozen. So you know now that a decoder will work with any encoder that fulfills the spec in the future. So the main differences compared to VP8 is the focus on quality for larger resolutions. Since HD is basically the new default, that's what everybody expects. We need to be able to handle that and 4K and whatever comes after. At the same time, doing it with a very reasonable decoding complexity and not increasing that too much while still making significant bandwidth savings. So the status is, as I said, in Chrome 29, we released VP9 and froze the bitstream. Quality from our measurements is very, very comparable to HEVC. Obviously, depends on implementations, and there are few and far between them right now to compare with. Complexity, significantly lower, which we believe is a really important factor in this, with the growing interest in mobile devices. So again, VP9, is that ready for WebRTC? Not yet. Needs more real-time communication optimization. Hardware, obviously, since we just froze the bitstream, will take a little while. But actually, already next year, there is scheduled, and there have already been the first step taken by some major SoC manufacturers to have that done for next year. And of course, we have VP8 that is an excellent codec to use for now. Should mention that YouTube has committed to using VP9 and is already doing that. So already today, if you go to YouTube and even without going to this specific site that I'm referring to here, a number of users will get VP9 all the time. So we are serving several % of the users with VP9. And we'll ramp that up very quickly to do everything, at least in the HTML5 video player with VP9. OK, so what's next? As I said, it's really about optimizing VP9, getting it better for real-time communication, for more efficient encoder, more efficient for lower-end devices, et cetera. It's also important to note that this is not the end game. The experimental branch is still open, and we welcome contributions. And as we already have some work going on with video, for example, where we will develop continuous versions of this. So see if we can get this going. So just a quick demo. It doesn't show much, of course, but what it's trying to do is to show at the same quality level. And you can see the bars there showing H.264 on the left and VP9 on the right. You can see the bitrate savings for that quality. So obviously that goes up and down at certain times, but it's pretty much 50% on average for a reasonable size corpus of test data. Oops. And OK, so that was basically what I want to talk about. So I'm going to wrap up. The main message here is that WebRTC, you hear it everywhere. But I think it's easy to misunderstand a little bit. It's not about replacing other apps or anything. This is about putting a tool in the hands of web developers and combine it with all the other things that are available. And that makes a really, really powerful way of doing things. And also putting high quality endpoints everywhere. VP8 is ready, is being used in WebRTC. It's a great codec for that. VP9 will be the next codec that will fit that, but it's not ready for WebRTC yet, but it's ready for streaming applications. And then we're working on what's coming after that, again, at web speed. Okay, thank you very much.